Hello, this is Sorijura. Originally, I was planning to explain soft references and async loading in this video. In the previous video, I even said that the topic was not as difficult as it might sound, so there was no need to worry. But when I actually started writing the script and reorganizing everything from the beginning, I realized that it was not an easy topic at all for someone completely new to MetaSound and Unreal Engine. So today, instead of covering soft references and async loading, I'm gonna explain a hybrid audio system that uses both 2D stereo and 3D spatialization. This will be the final episode of the Beginner MetaSound series. First, we'll add 3D particle sound to the cave area from our existing forest, cave, and wind ambience zone. In the current ambience blueprint, when the player enters the cave area, the ambient assigned to that area plays in 2D stereo. Now we're going to add a feature that plays short 3D particle sounds from random positions while the player remains inside the area. Right-click on empty space in the content browser and create a MetaSound source. Name it MSS, SFX, AMP, Particle, Cave, Mono. Open the MetaSound in the variables section. Create a wave array variable. Add the short one-shot sounds that you want to use in the cave area to this array. Connect onPlay to shuffle wave asset. Then connect to a wave player mono. Don't forget to connect the output and unfinished pins as well. Next, add a random float so that the pitch changes slightly each time the sound plays. Of course, the other areas can use the same structure. You can simply duplicate the MetaSound and replace the sounds inside it with ones that match each area. You all know how to do this by now, right? Next, return to Content Browser and create a sound attenuation asset. Name it ATT AMP Particle. Use the inner radius to set the range in which the original volume is maintained. Then use the fall-off distance to set the distance from that point until the sound becomes completely inaudible. Once the settings are complete, return to MetaSound, assign the attenuation asset we just created. Next, open the cave blueprint. This time, instead of repeatedly creating sounds with spawn sound at location, we'll create one dedicated audio component for the particle sound. This prevents multiple particle sounds from overlapping. It also allows us to easily fade out the sound that is currently playing when the player leaves this area. Click the Add button at the top of the Components panel on the left, add an audio component, and name it Particle Audio. In the Sound section of the Details panel, assign the MetaSound we created earlier. Then disable Auto Activate so that it does not begin playing automatically when the game starts. Now, create two float variables. Name them Particle Interval Min and Particle Interval Max. These two variables determine how long the system waits after one particle sound finishes before starting the next sound. Enable the eye icon so that the values can be adjusted easily from outside the blueprint. Set min to 2, max to 4. Next, create a Boolean variable, name it isPlayerInside. As soon as you create this variable, drag it into the graph as a set node. Place one after each branch in the existing overlap logic. When the player enters the area, enable the checkbox. Player leaves, disable the checkbox. Finally, create a time handle variable, name it particle timer. Alright, now right-click on empty space in the event graph and create a custom event. Name it schedule next particle. Drag from the white execution pin on the right, search for set timer by event. Drag the particle interval variables into the graph as get. Create a random float in range node. Connect the min and max variables. Then connect the green return value pin to the time input of set timer by event. Now drag from the red event pin on set timer by event. Select add custom event. Name it play amp particle. You can think of this red connection as telling the timer which event it should execute when the waiting time is over. And drag particle timer from the variables panel into the graph, select set, connect from set timer by events to the set particle timer. To summarize the flow so far, when the schedule next particle is called, a waiting time between 2 and 4 seconds is selected. Once that time has passed, the play amp particle is executed once. The scheduled timer handler is then stored in particle timer. Next, create a branch node from here. Drag its player inside as a get and connect it. We only want the particle sound to play while the player is still inside the area. Next part is a little more complicated. Let's go through it slowly. We're gonna calculate the position where the particle sound will play. We'll randomize only the X and Y positions. For Z, we'll use a fixed height slightly above the center of the box. Find box collision in the components panel on the left. Drag it into an empty space. Drag from the blue output pin, search for get word location. Drag from the same output pin one more time, search for get scaled box extend. Get word location returns the word position of the center of the box. Get scaled box extend returns the half size of the box from its center along each axis. Yellow pin of get word location, search for break vector, create another break vector from the get scaled box too. Now, drag from the X pin of the break vector connected to get word, search for subtract node. Connect the X value from the get scaled break vector to the second input. The result is the leftmost X position of the box. Drag from X value one more time, search for add node, connect the get scaled X value to the second input again. This result is the rightmost X position of the box. Right click and create a random floating range, subtraction result to min, addition result to max. This random float node now selects one X position between the left and right axis of the box. We can create the Y range in the same way. Finally, we'll calculate the fixed jet height. Drag from the jet pin connected to get scaled, search for multiply node, enter 0.5 as the other value. And from the jet pin of the get word, search for add node. Connect the jet multiplication result to the second input. This gives us the exact midpoint between the center and the top of the box. Now, right click on empty space, search for make vector. You can see the X, Y, and Z inputs, right? Connecting inputs appropriately, this vector is now the world position where the particle sound will play. Next, drag particle audio from the components panel into an empty space. Search for set world location node and connect the white true execution pin of the branch. Connect the yellow pin of make vectors to a new location. Then the particle audio component itself moves to the calculated position. To make the position visible during testing, we'll also add a Drew debug sphere node. Drag from set world location, search for Drew debug sphere. Connect the return value pin from make vector to the center pin. Set the radius to 20, duration to around 1 second. Next, create a fade-in node. Don't forget to set the particle audio as a target. Set the fade-in duration to 0.05 second. By starting the sound with a very short fade-in, the volume of the component will return to its normal level even if it was previously fade out. After that, connect the set wave parameter. Name it precisely just like we've done before. Now we'll create the logic that schedules the next playback time after the particle sound finishes. Select particle audio in the components panel. Click the plus button next to on audio finishes in the details panel. Drag from the white execution pin to create a branch node. Get its player inside and connect it. Then drag from the true pin of the branch, search for schedule next particle we made before. Now, when one particle sound finishes completely, the system checks whether the player is still inside the area. If the player is still inside, the system waits for another 2 to 4 seconds. It then plays the next particle sound from a different X and Y position. Because we are reusing one dedicated audio component, multiple particle sounds will not overlap with each other. Now move to the existing overlap fade-in logic, search for schedule next particle at the end. Let's also add one more print string for testing. Move to the end overlap logic, drag from fade out node, create another fade out, make sure its target is particle audio. Set the fade out duration to 2 seconds, just like the existing 앰비언스 fade out. Drag particle timer from the variables panel as a get. Drag from particle timer, search for clear and invalidate timer by handle. Connect this node at the end of the execution flow. Let's add another print string here as well. Alright, shall we check? Can you see it? The 2D stereo layer maintains the overall environmental background. At the same time, the 3D particle sound provides detailed positional information within the space. It is a simple structure, but there seems to be countless ways to expand and apply it, right? And I'm not planning to stop here. This time, let's apply the same hybrid method to an impact sound. For example, the attack and material sounds that communicate the collision position can be processed in 3D mono. A room with a frequency test that supports the weight of the attack can be separated into a 2D stereo. I haven't personally confirmed whether this is true, but I've heard that the Dark Souls series uses a similar method. Anyway, let's begin by creating a MetaSound source for the 3D layer. Name it MSS, SFX, Hybrid Impact 3D Mono, just add a suitable magic impact sound. We're gonna create a separate sound attenuation asset for the 3D impact sound. Name it ATT SFX Hybrid Impact. For this test, we'll use a relatively narrow inner radius so that we can clearly hear the distance changes. The fall-off distance is the distance from the outside of the inner radius to the point where the sound becomes clearly inaudible. We covered that earlier, right? If this value is too short, the 3D sound may disappear as soon as the player moves slightly further away, so I'll give it a little more range. Don't forget to assign the attenuation asset to the MetaSound. Now, create another MetaSound source for the 2D layer, name it MSS SFX Hybrid Impact 2D Stereo. Set the output format to stereo. For this MetaSound, we'll add a low-mid frequency cinematic impact that supports the sense of weight. There is no need to assign an attenuation asset separately. We now have two MetaSounds with separate 3D and 2D roles. However, there is currently no separate skill actor in this level. Technically, that part is not really our responsibility, but I still need to explain the system, so let's quickly make a simple test actor. Right-click in the Contents browser and create a Blueprint Actor, name it BP SFX Hybrid Preview. Open the blueprint, in the Components panel, search for Cube and add it. Then, in the Details panel, find Auto Receive Input, set it to Player 0. This allows the actor to receive keyboard input without creating a separate input system. Anyway, right-click on empty space in the event graph and create a custom event. Name it Play Impact 3D, create spawn sound location after this event. For the sound input, assign 3D MetaSound. To play the 3D sound from the cube's position, create Get Actor Location. And connect Get Actor Location to the location input of spawn sound. Next, create another custom event, name it Play Impact 2D, create spawn sound 2D after this event. Obviously, put in 2D MetaSound. Now we'll create the logic to listen to 3D and 2D layers separately. After that, we'll listen to both layers together. Right-click on empty space to create a keyboard event for the number 1 key. From the press the execution pin to call Play Impact 3D. Then create another keyboard event for the number 2 key. Please connect Play Impact 2D. Finally, create a keyboard event for the number 3 key. After the press the execution pin, create a sequence node. Connect Play 3D to then 0. Connect Play 2D to then 1. Let's also connect the print string to each input so that we can check each layer. Now, place skill actor in the level, run the game and press the number keys. The 3D mono layer plays from the cube's position. If the player turns away from the cube or changes the distance from it, the direction and volume of the sound will also change. The 2D stereo layer plays without any attenuation based on the distance or direction between the cubes and the player. When you press 3, the 3D mono layer communicates the cube's position and distance. The 2D stereo layer supports the impact feedback that the player needs to feel. 2D sound is too loud right now. Let's adjust it. And that's it. In a real project, ask the developer to play the 3D mono MetaSound at the skills collision point. For major player skills or powerful close-range boss attacks, the 2D stereo layer can also be triggered from the same event. I demonstrated it here with simple keyboard input, but by using a trigger system we learned earlier, this could become an action sound system that delivers a strong impact when needed. This concludes the beginner MetaSound series, but this is not the end of the MetaSound videos. There is still a lot I haven't covered yet. The next video will be about Wise implementation. The Wise series will also have around 9 or 10 episodes. After the beginner Wise series, we'll return to the intermediate MetaSound series. I'll cover soft references, async loading, submixes, and the other topics I couldn't explain this time. Thank you for watching the beginner MetaSound series. See you in the next video.